Hi all, in this demo we will be exploring Microsoft Fabric from different point of view, from what Microsoft Fabric looks like to a data engineer, what it looks like to a data scientist, what it looks like to a Power BI developer. Before we jump ahead, what exactly we are going to do is we will be predicting fraudulent transactions, and we will do some machine learning to see which are the highest fraudulent cities in EU, right? And the strategy is to ingest data from multiple data sources, clean the data, and apply some machine learning algorithm to predict the fraudulent patterns. For any data project, the most important bit is to bring the data into a single data lake kind of thing, right? So if we move ahead, what we will need, we will be bringing data from 4 different sources, and this is your data engineer persona, right? The 4 different data sources are your data from ADLS Gen2, which has your credit card transactional data. Then we have another data about the country specific, which is in AWS S3. We have city data. City data is divided into 2 parts, and I will be showing you how to bring in data using Dataflow Gen2 and how we can bring data using Onelake Explorer. Once all the data is brought to your Onelake, and I'll show you what Onelake is, what your lake house is, then we will be using machine learning algorithms in Fabric Notebook to analyze and predict the fraudulent transaction. After the fraudulent transaction has been predicted, we will be storing the predicted outcome into the lakehouse again. Since we are bringing data from 2 sources, especially for the cities, and we literally want to create one final outcome for the city, we will be merging the cities data using Visual Query, and we'll create a view. The idea of this exercise is to show you kind of a low code, no code feature of Fabric. And then once all these 3 data sources have been brought into Onelake as a delta file, we will be creating a model, data model, and then we will create a Power BI dashboard, which will be shown to the senior management that okay, which are the cities where the most fraudulent activities took place, right? So this is the overall demo journey and demo agenda. So let's see the data sources first. If we see our data sources, so this is the data source into one of the container called Fabric Storage N. In this container, we have a container called credit card. Inside this credit card, we have credit card.csv. This credit card.csv file contains all the transactional data. Another data source is in S3 bucket, right? And this bucket is called country data for Fabric, and inside this bucket we have a file called country list.csv, right? And then once 2 files are in my local, which are your city list 1 and city list 2, right? These 2 files are not needed as of now because they are in your cloud in ADLS Gen2 and in Fabric. Now let's see the first thing, how we gonna be bringing data from ADLS Gen2 using Shortcut. So what I have done here, I have created a workspace called Fraud Analytics, right? The creation of workspace is very easy. When you go here into your workspaces, you can go for new workspace and give it a name. I created the workspace called Fraud Analytics. Inside this workspace, the next thing what I did is I created a lake house called Fraud Data Analytics. Again, creation of lake house is easy, super easy. You need to go to new, you need to go to lake house, and you can give any lake house name here. Let's say I want to create a lake house called test, right? So within a seconds, a new lake house is created. Into lake house, one thing which I want to focus on is we have 2 folders, one is tables and one files. The difference is anything which will be moved to tables will have the storage format as delta. In files, the storage format can be anything. It can be CSV, JSON, delta, Parquet, whatever the raw data file is, right? And with every lakehouse, you will have your SQL Analytics endpoint created by default. We will cover this later. If I go to my fraud analytics workspace again, so first thing what we have to do, we have to bring data from ADLS Gen2, which can be in any tenant, right? So what we have to do, we have to create a shortcut. In this shortcut, we need to bring data from ADLS Gen2. Now it will ask for a few things like which URL you want to bring in data from, like what is the URL of your container, right? And then we need to ask, we need to see what connections we have. So let's see how to fill this. So what I've done, I have created a container called fabric storage n. So let's copy this container name. Let's paste that container name into the URL, right? And then what we'll do, we'll copy this URL here. So this is the URL, okay? And it will create a new connection for us. Now it will, we can authenticate our connection using multiple ways: account key, organization account, SaaS, and service principal. For this particular demo, let's use service access signature, shared access signature. How to bring shared access signature here? You need to go to your security and networking, go to shared access signature, and it will ask for, okay, which shared access signature you want to generate. What I've done, I have generated this shared access signature and I have copied it into my notebook. So I'll copy it here, copy from here. I'll go to access token, go for next. And now it is asking me what is the name of the shortcut, like in your lakehouse. So I'll say this is my credit card data, right? Now it is asking me, okay, what is the subfolder name or the container name, right? So this is my storage account. In this I have multiple containers. The container which I want to bring data is from is called credit card. So this is my credit card data. So I'll just paste that container here. I'll say create. And if we see this, credit card data is now brought into our Onelake, into my lakehouse, right? If we see it, the preview is available. It's exactly the same data which is available into my ADLS Gen2. So first data source is ingested. The special thing about the shortcut is it will be a live connection. Anything which will change into my ADLS Gen2, it will reflect here, right? Now the next thing is we want to bring in data from, so the credit card data has been brought in. The next thing is we need to bring in data for country, which is in my S3 bucket, right? Into AWS S3 bucket. So let's see how we need to do it. We'll go for create new shortcut. Now in this time we need to bring data from Amazon S3 AWS. So it is asking me for URL. So let's see what URL is. So we go to fabric, and into fabric, into your AWS S3, we have buckets. In my bucket, I have created a bucket called country data for fabric. Here we need to go for copy URL, right? Copy URL is done. We'll paste that bucket here. Just remove the file name, because the file name, anything which is inside this bucket will be automatically copied as shortcut here. Okay, so this is done. It is asking me for access key. There is only one way to authenticate, that's access key only for the S3, and it is asking for access key ID and shared access key. Now in AWS we need to go for IAM. In IAM we need to go for here we will see manage access keys, right? Inside manage access keys, what we will do, we will create a new access key. I have created two already, and let's do one thing. Let's delete this just to make sure because I have already two created here. I'll say deactivate, and I'll say Control V, and I'll say deleted, just to show you guys to create a new access key. It is allowing only two access keys for me. So I'll say I'll understand. I'll say create access key now. So what we'll do now, we will copy this access key to the access key ID. This is here, right? And then this one, say create access key to here, and we'll say go to next. So it is asking me for the shortcut name. It is your AWS country data, right? There is no subfolder name here because the file name is directly inside this particular bucket. I'll say create. So what we see here now, the data about country from AWS S3 bucket has been copied here, and again this is shortcut and it's a live connection, right? So two data has been copied successfully. The third data is your what we call it, city specific data, and we know I will show you how to bring in data, city data, using two different ways. The first and the easiest way, which I like, is, so you know what, this is your city data, city list one. So what I'll see, I installed Onelake Explorer here in my local, and Onelake Explorer is very similar to OneDrive, but it is pointing to the Onelake, and all my lake houses will be visible here. So my lake house name is fraud analytics, right? So let's see if we have fraud analytics visible here. See, fraud analytics is visible here. If we go further down, we will see that we have fraud data analytics lake house is visible here, which is your fraud analytics lake house here, right? So inside this, what we should have multiple folders like prediction, credit card data, AWS country data. Let's see if we go further down, we have files and tables similar to the files and tables here. And if we go inside files, see what we have here, we have exactly same AWS country data, credit card data, and we have data from city source one, but I don't want it as of now. I'll delete it, right? And I have two shortcuts created. So what we can do here, we can literally see AWS country data, which is your S3 bucket, into my local, right? So I'll go back to files, and this is city list one. I'll say Control C here, and I copied that file. I go to fraud analytics, I go to lake house, files, and I'll say Control V. So my city list one is copied here. Now let's go to our files and let's see whether city list one is available there. And what we'll do, we'll refresh it, and my city list one is now available here. So this is my city list one is brought in now. Now next thing, if you want to bring city list in from another way, what we can do, we can go for get data, right? We can go for ADLS Gen2, and let's name this ADLS Gen2 first. City list 2, right? City list 2, city list 2, and we want to bring data from Excel, and we want to, let's say we want to browse the file here, and we go city list 2. So it will upload the file, it will create the connection to my local. Upload done successfully. It has created the connection to my personal SharePoint. I'll go next. And I have the data in my sheet 1, so I'll say sheet 1 here, and this is my data, right? I have ID, name, state, alpha 2, longitude and latitude. I'll say create. Now, so the data has been pushed in here. So the next thing is what we need to do. We need to publish this data and we need to select the data destination, right? So it is applying further steps and it is bringing in data into your Dataflow Gen2. Now what we have to do here, see, it is asking for the data destination. By default, the data destination has been selected as Workspace has selected as fraud analytics, because that's where I created this Dataflow Gen2, and my lake house is fraud data analytics, and that's what I wanted. If this is not there, we can literally select any workspace, any lake house, and I'll say publish. All right, so what it is doing for me here is it is running my city list Dataflow Gen2, and once this is done, it will create a table for me in the city called city list into my table folder. So let's see. So I already have few tables created. I'll refresh it, and so I should have a new table created here. See, city list is published successfully, and if I refresh it now, it might take a couple of seconds more. Or let's go to fraud analytics workspace and see, it is still running. So if you see this refresh button going on here, it means that it's still running. Till the time it is running, let's do one thing. We'll go back to our fraud analytics workspace. Now what we need to do, first of all, table called sheet1. Basically the table name is the sheet name in your Excel. What I can do here, I want to rename this, right? I can rename this as city list 2. So now we are bringing all these files, what we have imported from different data sources, from this file folders to the tables folder, right? So we have city list 1 here, and we go for load to tables. We want to create a new table, and let's the table name is the same, city list 1, and we'll go for load. So it will be loading the table from files folder, and it is converting this CSV into Delta format, and I'll show it to you in a couple of seconds. We'll do the same thing for country list.csv, load to tables, and we go for new list, new table. Okay, so it is asking me for please wait for current operation to finish before sending new request. I'll say cancel, and let's wait for it to be complete. Okay, so it's done, and what we can see that we have a new table called city list 1 here, right? Now let's do the same thing for country table here, and we want, let the table name be the same, right? A country list, and CSV file, it should be quick. And after this we'll do the same thing for your credit card data. So we have, see, we have city list 1, city list 2, we have country list which is created for us. For the credit card transactional data, this is where we want to do some sort of machine learning to predict the fraud. So what I have done here, I have created a notebook called fraud detection. In this fraud detection notebook, we will be doing multiple things. First thing, we will be installing some custom libraries. We will load the data. We will understand the process, some sort of exploratory data analysis. Then we will use some scikit-learn to do the machine learning. And then we will use MLFlow to track the experiment, and we'll see how Fabric auto logging feature works. At the end, we will save these models, machine learning models. So there will be multiple machine learning model created, and we will save the highest performance machine learning model, and after that we will load the machine learning model for scoring and make predictions, right? So first thing first, what we have done here, we have set some Spark context, and we have done the V order enabled, we have done delta optimization enabled, and then we have done some sort of bin size. So what we are doing here, that okay, V order is a write time optimization to the Parquet file format that enables lightning fast reads under the Microsoft Fabric compute engine such as Power BI, SQL, Spark, and others. Power BI and SQL engine make use of Microsoft Vertiscan technology and V-ordered Parquet files to achieve in-memory data access times. Spark and other non-Vertiscan compute engines also benefit from V-order files with an average of 10% faster read times. In some scenario, it can reach up to 50% more performance gain. So it's a no-brainer to use this sort of configuration setting here. Next thing, I'm installing a library called IMLearn. I'll show to you what this library is, but the important feature is it just pure Jupyter Python notebook, and you can use %pip install any library what you want to install. Then we are loading a data set. The data set is credit card transaction data. Into this data set we have features, right? So these features are V1, V2 till V28. The fraud detection data sets contains credit card transaction from September 2013 that European cardholder made over the course of 2 days. The data set contains only numerical features because of principal component analysis transformation applied to the original features. PCA transformed all features except time and amount to protect the confidentiality. The original features are not provided. So basically when we see the data set, we have V1, V2, V3 till V28 features are the principal component obtained from PCA. Then we have time and amount. So let's go to the here to the end, and we have see that we have amount class. So amount feature is the transaction amount. You can use this feature for example dependent cost sensitive learning. Then we have class column is the response or target variable. It has value 1 for fraud or 0 otherwise, right? This is very imbalanced data set, and so basically there are only 492 transactions out of 284,000 transactions are fraudulent, right? So if we see the percentage, only 0.172% of the overall transactions are fraudulent. So basically this is why we have used a library IMLearn. So this is to do with the imbalanced data set, and we will see the more usage later in the notebook, right? Then we have set up some data folder here. We have set up which data file we need to use here, and then we have kind of for the MLFlow is machine learning container. Basically when we do any machine learning experimentation, all the artifacts of that machine learning experimentation will be stored in MLFlow. So for this particular experiment, we have named this as AI sample fraud, and at the end we will see there is a new container called MLFlow container called AI sample fraud will be created for us, and all the artifacts of this machine learning exercise will be stored there. So setting up MLFlow experiment tracking. So here experiment tracking is the process of saving all the relevant experiment related information for every experiment you run. Sometimes it's easy to observe that there is no way to get better results when running a particular experiment. In such situation, you will better off simply stopping the experiment and try a new one. The data science experience in Microsoft Fabric includes auto logging, which significantly reduces the amount of code required to automatically log the parameters, metrics, and items to the machine learning model during training. This feature extends MLflow auto logging capability and is deeply integrated to the data science experience. Using auto logging, you can easily track and compare performance of different models and experiment without the need of manual tracking. So, and just 3 lines to do it. You need to import MLflow, then you need to set the experiment name we have set earlier, and then you have to disable the MLflow auto logging true to the true, right? And then what we have done, it's simple spark.read.format. We have enabled the header is equal to true. We have asked it to infer the schema, and then we have load the file from our ADLS Gen2 shortcut, right? Then we did some exploratory data analysis here. In this exploratory data analysis, we will first explore the raw data and the high level statistics, and then we will transform the data set, cast the column into correct types, and convert them into Spark data frame. Convert them from a Spark data frame to Pandas data frame for easier visualization. Finally, we'll explore and visualize the class distribution. So what we will see is the same data set. We have v1, v2, v28, and then we have amount class, right? The same thing what I have shown in the beginning when we were talking about the data set. When we print the schema, we can simply see the same thing. It is amount class and ID. ID is a integer, which this ID basically is an ID which will act as a join between our country file and the city file. Then we will be casting the data set into correct types, and then we will convert the data frame into Pandas data frame for visualization, and then we'll print. Okay, we can clearly see that okay, number of fraud, no fraud is 99.83, frauds are 0.47 and 0.17%. The class distribution shows that most of the transactions are non-fraudulent. Therefore, the data processing is required before model training in order to avoid overfitting. And this is where our library will come in picture. We can again see the same thing into some sort of bar chart. We will use Seaborn library here and Matplotlib to see that okay, the very small 0.17% are fraudulent transaction. We will do some sort of exploratory data analysis here, and then we will use a light GBM model to classify the fraud transaction. We train the light GBM model on the imbalanced data set and also on the balanced data set. We will be using a library called Smart. We will discover it later, and we will compare the performance of both models, right? So we are just preparing test split here that okay, 15% are test and remaining 85% is your train. Apply Smart only to the training data set and not to the test data set. When you score the model with the test data, you want an approximation of the model performance on the unseen data in the production. For this approximation to be valid, you will test the data to be represented in production data as closely as possible by having original imbalanced data set. We are applying Smart here, and see this one. So basically we are doing Smart and we are putting random state to 42 here. Then we are updating the MLflow auto logging configuration to track additional matrix parameters by setting exclusive to the false. And this is where all those metrics, anything performance parameters, anything which is happening to files and everything will be stored in this auto logging, and I'll show it to you later. Now we will be using light GBM to train 2 models, one with Smart and one with imbalance. So basically Smart model is for your balanced data set. So if we perform a Smart on the imbalanced data set, it will convert that into balanced data set. And then we will train light GBM for imbalance and balanced data set and define the evaluation matrix here, right? And we know the target column for us is class. So this is what we want to predict from both balanced and imbalanced data set. So once the training is done, we will see the feature importance here, and we will see basically the importance of feature for each of the model that we have trained on balanced dataset and imbalanced dataset both. And then once all these trainings have been done, we will predict the fraudulent activities. So before we jump into the details, all these things, basically what we see here, that okay, we are using Synapse ML here to do machine learning here. From Synapse ML we are using compute model statistics, and in the compute model statistics we are labeling the column target column, and we are using this code label columns as prediction. Okay, we prepared our confusion matrix for both imbalanced and balanced dataset, and at the end we have stored the prediction results into file folder into prediction called batch predictions. Okay, so if I go to my lake house again, and I'll share this notebook later with you guys if you guys want. So in the the prediction and batch predictions. Okay, and now same thing, what we can, when we go inside this, we have your Parquet delta file created. Now if we want to create a table out of this, right, so we can simply go load to table, and what this is your predicted fraudulent transaction. So there is no delimiter here because this is Parquet file, and we can simply load it. So what I've done here, I have loaded predicted fraud here. Okay, so now what we have done till now, we have loaded all the data files, we have converted the data files into delta files, we have done some sort of machine learning and stored the predicted fraudulent results in your files. We have converted them into predicted fraud file. Okay, let's see one more thing. Let's explore what SQL analytics endpoint looks like here. So we know that we have let's refresh this. So let it get loaded, and then I'll show to you how to use SQL Visual Query to bring data from multiple different data sources. Next thing what we have to do, that we have your CityList1 and CityList2, and we need to merge these two queries, right? There are multiple ways to do it. One way which I like, and it is the way for the people who are not very proficient with SQL or coding, right? So they need to go for SQL endpoint and then go for new visual query. And in this visual query, what we want CityList1 first thing. Let it get loaded. CityList1 is loaded now, and we will bring CityList2 here. And what we have to do, we need to go for first, second, and we need to append these, right? So we'll go for append queries as new, and we want to append CityList1 with CityList2. And once this is done, we want to save this as view. Okay, so, and we will call this city list complete. Okay, and we'll say okay here. So what it's done, it created a new view for us called city list complete. This is the view. So what we have done now, we have all the tables. We have country list, we have predicted fraud, we have city list full. Next thing what we have to do, we have to create semantic model on which we can do the visualization. So in same semantic SQL endpoint, we have model here, right? In this model, we have all the tables, and then we have default dataset objects. When we go to default dataset object, let's remove this from here. So what I have done here, I have we have all the data here, right? For example, your city list, source 1, source 2, country list, your predicted fraud and everything. So we know that what we need to do, we need to predict the cities which have the maximum or the highest number of frauds. So if we want to join ID from your predicted fraud to the ID of city full data, so what we will do, that bring ID to here, and it will ask you whether it's one-to-many relationship or one-to-many. So we will say that so we have fraud, so fraud can happen in multiple cities, right? So it will be many to one, if I'm not wrong. So we'll say it's many to one. We can change it to anything, right? And then so this is how we will do the metadata modeling or the semantic modeling. And then once this is done, we will go back to fraud analytics. The last step is your visualization, right? So when we see here, one thing which again I forget to mention, so we have created a MLFlow model called AI sample fraud. If we go inside this AI sample fraud, we have created two experiments into it, right? So one is smart data, which is for the balance to make the data balance, and one is on the raw data. If we go inside these models, we have created confusion matrix, feature importance, and same for the raw data. Okay, and literally this is what we have done into a notebook. So MLFlow is a way to kind of store all the artifacts of your machine learning modeling. If we go back, what we can see that this is ML model what we have created inside AI sample fraud MLFlow, and light GBM is the more machine learning model what we've used for the prediction. So what we have done here, that this is your semantic model, default semantic model, what we have make the joins from city to country and to the predicted fraud data set. Okay, let's go here 3 dots again, and we will say create report of our own, right? So let's do one thing. We have our city full list here, right? In city full list, one thing which is interesting is it is considering longitude and latitude, right, as number. Longitude, we don't want to summarize it because this is longitude, and I know this is your geographical longitude data. And I'll go to advanced and see the data category is uncategorized, but I know that this is your longitude, right? And this is your latitude, and this is how you will change the things in your data model. Okay, and I'll go to my untitled report, and now let's say city full data. See, it has changed to longitude and latitude, exactly same report. Let's see. So this is count of city full, the same thing, and this is how it will look like. Okay, so basically it will show you which cities have the highest fraud, and the bubble size will represent the amount of fraud what it took place into the cities. So basically what we have done in this demo is we have shown you how to bring in data using shortcuts from ADLS Gen2 and S3, how to use Onelake Explorer to bring data from your local, how to use Dataflow Gen2 to bring in data, and then how to create tables from your files and move them into table folders in Delta Lake format, right? So